Hello, I'm Guamegi. Let's look at the liquid ring type. Generally, it is used with water. Oil can be used in conditions with corrosive gases instead of water. Liquid ring type is the principle of suction, compression, and exhaust while the internal eccentric impeller rotates. Unlike dry screw, there are many auxiliary facilities. Let me explain the processes and devices first. First, there is a vacuum inlet and a liquid inlet that supplies water. It is inhaled at the same time, and it goes through a compression process. The used water is discharged into the water tank with the gas. The gas is exhausted and the water is cooled and reused through a heat exchanger. There is no need for a heat exchanger. If there is no heat exchanger, the pump efficiency is better. However, a lot of water use increases the cost. If you have a heat exchanger, you need an inlet pipe that replenishes water as it evaporates. The manufacturer usually puts the water tank in the size to store the amount of discharge for about 3 minutes. The height is higher than the water inlet, allowing it to be inhaled again. The heat exchanger is designed to be about 1 square meter for 100 cubic meter per hour. Liquid ring type exhaust selection is special, so listen carefully. As shown in the table, the exhaust was calculated from the vacuum pump first round. The exhaust was 1.1 times the design margin of the sum of the condition value and the material characteristics value. The dry screw applies the exhaust as is. However, there are important things to consider in the liquid ring type. For example, when the water temperature to be used is 20 degree, and the required exhaust is 400 cubic meter per hour based on 30 torr, how much should the vacuum pump exhaust be? The most important thing in the liquid ring type is the temperature of the water temperature. Let's look at the exhaust graph according to the water temperature and vacuum. Check the temperature curve of 20 degree and check the vacuum level in use. There is a point where the water temperature curve of vacuum degree meets. The value of this point is 0.78, which is the maximum exhaust efficiency. If you calculate it, you can see that a pump of 512 cubic meter per hour kappa is required by dividing 0.78 by the required exhaust of 400. Second, the usage conditions have changed, so how much exhaust is possible if I use 50 torr? The water temperature is the same, and the maximum exhaust efficiency is 0.9, if you check the vacuum level of 50 torr. So if you multiply by 512 times 0.9, you can exhaust 460 cubic meter per hour. Did you know that the capacity of the pump depends on the temperature of the water? And the point where the efficiency is 1 is 15 degree. The lower the temperature, the better. But if vacuum below 25 torr is required, I recommend using a combination of boosters. When selecting a pump, don't mention the graph, ask how the manufacturer designed the exhaust. In my experience, there was a manufacturer that selected a pump without knowing this, so I remember telling them. Nope. Now I'm going to look at the inside section and explain the principle. Picture shows the entrance to the inner casing. The upper part is gas inhaled, and the lower part is water inhaled. On the left is the principle of exhaust. If you look inside, you see an eccentric impeller, which is a compression structure. It rotates clockwise and inhales, and the space is gradually reduced and compressed. The liquid compresses the gas molecules. At this time, the generated heat and the frictional heat of the impeller are exhausted. When exhausted, the water temperature rises by 3 to 5 degree. To reuse this water, install a heat exchanger. Pump management is fine as long as there is no cavitation sound. Please refer to the video above for the sound of the cavitation. The water sealing method has many auxiliary facilities, but it is useful for the process of sticking or corrosion like a chemical factory. It can be used. I think liquid ring type is difficult, but please take your time to organize the contents. There may be parts of the content that conflict with expert opinions, but I'm sure this will help you. Thank you.